You said it was going to be look and click. Those guys are saying look and click or word for word. They have 9 lives. They have 9 lives. I have one. I'm careful. So I will leave 28. I'll come back to 28. Huh? 27 is, yes, I'll come back to 27 too. You know, I've not touched balancing radars. Don't leave yet. I'll teach you how to do that. I'm just trying to see if we can rush the theory. If I can stop at 40, you should go home and do the remaining one. The remaining ones are, they are what we have done. You get? So number 41 downward is what we have done before. So that one is your own. Just go home and use active recall to answer them. You get? So that in case they change the question, you'll be able to do something. 29 said, which of the following can be a Lewis acid? What is a Lewis acid? Huh? Okay, Lewis acid, they are electron what? Acceptors. While Lewis base, they are electron donuts. So the right answer there is BF3, boron trifluoride. Boron trifluoride is a Lewis acid. It accepts electrons. Are you following? It accepts electrons. So take note of that. So which of the following is the correct identification of oxygen gas? How do you test for oxygen? It rekindles a glowing what? Splinter. That is to show you that oxygen supports combustion. True or true? What about hydrogen? How do you test for hydrogen? Eh? It burns the pale blue flame and produces what? Hydrogen gas. How do you test for chlorine? Now, this option A is the test for chlorine. That damp low litmus paper turns red, then white. Is the test for what? Chlorine. Are you following now? Chlorine carry out bleaching, right? Now, sulfur fluoride also carries out bleaching, also, right? But the way they bleach is different. Chlorine, chlorine bleaches by what? Oxidation. Are you following? It needs oxygen. If there is no oxygen, chlorine cannot bleach. That's why you have to add water to it because it gets the oxygen from the water. So chlorine needs oxygen to bleach. So it bleach by what? Oxidation. But sulfur fluoride, SO2, bleaches by what? Reduction. So take note of this, please. Also, no flame test. I don't know. Maybe I don't know if they were asked, but just no flame test. Like sodium. Sodium is which color? Golden yellow. Calcium is which color? Brick red. Potassium is which one? Eh? Elac. Elac. Then copper is which color? Blue. Are you following now? Those four, just know only those four. Sodium is golden yellow, calcium is brick red, potassium is elac, copper is blue. Know those four flame colors. They will not ask you anyone above those four. They won't ask you. Number 31. Say which of the following is not a way in which a solid solute can be made to dissolve more quickly in a liquid solvent? Of course, when you stir, the stuff dissolves quickly, right? Let's say you put a particle inside water and you are stirring, the stuff will dissolve quickly. When you heat and you shake, it also dissolves quickly. When you grind to powder, it dissolves what quickly. For example, now, if you put a cube of sugar in water and you put those granulated sugar inside water, which one will dissolve faster? The one you ground, because there's larger surface area, so it dissolves faster. By pulverizing, pulverizing also means grinding too. Are you there? It's just another name for what? Grinding. So the answer to that question is none of the above. Which of the following is the correct laboratory practice? Of course, now they're testing you on usage of the lab. So you know what that one is. All of the above is the answer. When you want to smear, how do you smear? Do you take the stuff like this? Eh? You don't take it like this. Some of you, I saw you doing your practical, you were doing like, oh, kill yourself. Oh. So you go like, it will hire you. Go on, knock you off. You get. There's something called wafting technique. You get, so if the stuff is there, use your hand to just do it like this. That is wafting technique. That's how you smell. Don't do sorry. When you say wait, man, I smell like till they smell like rotten egg. God knock you off. Okay. You don't eat in the lab. That is a bad practice. And also you don't put dirt in that sink. Also a bad practice. They test the question here. What is a standard solution? Now, a standard solution is same thing as a stock solution. Are you following? That's another name for it. Solution that you know the concentration. The concentration is accurately well known. So the answer is there, option D. Suitable primary standards. Now, what are primary standards? Now, primary standards have some features you should know. For a substance or for a compound to be called a primary standard, that substance must have some features. For you to be a primary standard, you must have some features, such as the primary standard features. Please memorize this. One, it must be stable. It must be stable. Two, must have a known formula. Take note of that. Three, must be constant. Must be constant when exposed to the atmosphere. To the atmosphere. Then number four, must be pure. Must be pure. That is high purity. High purity. High purity. High purity. So must be stable, must have a known formula, must be constant when exposed to the atmosphere, must be pure, that is, must have high purity. Those are the features of primary standard. So any substance that if you expose it to the atmosphere, it will absorb water and change to something else is not regarded as a primary standard compound. So if you look at sodium hydroxide here, the reason why sodium hydroxide is the answer is because sodium hydroxide is deliquescent in nature. Are you following? It is deliquescent. Of course, you know what deliquescent is, Abby? Deliquescent are substance that when exposed to the atmosphere, it absorbs moisture, Abby, and forms solution. Then what about hygroscopic? They absorb moisture, but they don't form solution. They just become moist. For example, your soap. If you leave your soap outside and come back the next day, it will absorb dew and it becomes sticky, right? It does not form solution, but it becomes sticky. So that is hygroscopic. They will have a fluorescence. Fluorescence is when a substance loses water to the atmosphere. Example, washing soda loses 9 molecules of its water to the what? Atmosphere. So that is efflorescence. Fluorescence is different from effervescence. Effervescence is when a substance emits gas. If you react HCl with sodium carbonate, it's going to emit a gas called carbon dioxide. That is effervescence reaction. Production of gas, the one with V. So the reason why you cannot use sodium hydroxide is because it is what? Deliquescent. So therefore it is not, it fails this rule that says must be constant because it's going to absorb water. So that's why sodium hydroxide is not correct. So you should know some of this compound. Sodium hydroxide, we also have magnesium hydroxide. So magnesium hydroxide. Then we also have calcium chloride. We have FeCl2 also. These are deliquescent compounds. These ones are deliquescents. They are deliquescents. Then hygroscopic, under hygroscopic, we have H2XO4, we have um, sodium nitrate, NaNO3. Then under, you don't need a fluorescence, but a fluorescence is washing soda, which is your Na2CO3.10H2O. So I have your Goba salts also. Just change the CO3 to SO4. You have Goba salts. So that is it. Is it Goba or Gobla? Eh? Goba. Okay. No, I'm not used to this stuff. This is not the life I want. I don't know if you want to live big life, like want to be president. I don't know if you want to be president. There's some of you when you were like 4 years, 5 years, you wanted to make a difference. Do you still want to make a difference, or you just want to live? Oh, you are okay. When they ask you, what do you want to be in future? I want to make a difference. Now you the cause issue now. Oh my god. So they love using sodium hydroxide. If you look at 34, it said the standard sodium hydroxide solution cannot be made by weighing accurately a given mass of the solid and making it up to the required volume of solution because it is what? The liquid set. So they I don't know, they just like using sodium hydroxide. Calcium oxide also, yeah, this guy is hygroscopic calcium oxide. Then silica gel is also hygroscopic. Silica gel, that is SiO2, your normal sand formula, it has the same formula. Silica, that is hygroscopic. In case they ask you, what do you, all drying agents are what? In case they ask you, what will you pick? Are they the liquescent or hygroscopic? All drying agents are hygroscopic, not the liquescent, they are hygroscopic. All drying agents are hygroscopic. And the best drying agent is what? Silica gel. Okay. Number 37 is the easiest question. Yeah, I'm not solving that. My grandma can solve that. You get. So mass, they say calculate the mass percent. Mass percent is what? Solute over what? Solution, Abi? So that is the formula you use. Solute over solution. Mass percent. Solute, that is MP is equals to SONN, sorry, SOUN over what? SONN times 100%, where SONN is the solvent plus the solutes, right? So in that question now, it's going to be 1 over 100 plus 1, which will be 1 over 101 times 100%. So if you do that, you have your answer there, which is 0.99%. So that one is easy. Everybody can do that one. Number 38 says, in a natural delta environment where there is emission of gases through combustion of natural gas, what are the gas emitted when you burn natural gas? What are the gas emitted? CH4, methane, hydrogen, which other one? CO2, SO2. And these gases, they cause the stuff to become what? Acidic, right? So they will make that region become acidic. So if maybe rainfall falls in that place, the rain is going to be acidic in nature. So in natural delta environment where there's emission of the pH of the rainfall will be acidic because of those SO2, CO2, CH4, hydrogen that is produced. So if you look at the options there, the only figure that represents an acidic figure is 4.0, right? So that is the answer. That is why the answer is that. Okay, 39, we have answered it before. 40 said all the listed compounds are strong acid except, of course, H2SO4 is a strong acid, HCl is a strong acid, HNO3 is a strong acid, right? Abi? They are all strong inorganic acid. Now, hydrogen carbonate, which is your normal soda water, is not a strong acid, it's a weak acid, right? It's a weak acid. It is formed when you dissolve carbon dioxide in water. So if you dissolve carbon dioxide in water, you will form soda water, which is hydrogen carbonate. a weak acid. So option D is the right answer there. So like I said, 52 down to 70 is um, a prototype of what we have done before, but in new formats. And I purposely do that because I wanted you to go and have something to work on these nights. So when you get to, you do 41 down to 70, the remaining 30. Just do active recall. All these things you have done is what you'll be doing there. So it will help you to see if maybe you can face tomorrow or leave it and run for another day. So let's do that redox reaction now. So that the reason why I left it at the last is because I don't want you to forget. I want you to learn it. There's a easier method of this redox reaction. I like this. The easier method is for, I don't know if you like soft life. Soft life, baby girl, soft life, baby boy, soft life. Some of you like suffering. I don't know why. So if you know you don't like suffering, the easier method is you just look at the options. Check the one that has the atoms balance, the ions balance, like the charges balance. Anyone that have the atoms balance, the charges balance, that is the answer. You get. Well, let's say for example, that some of us we love to prove. Some of you want to just prove that you have arrived. I don't know why. So I'll teach you how to prove that you have arrived. If maybe you like that one. So let's look at balancing redox reaction, the step-by-step guide. Please, I'll not explain this stuff two times. My brain just warned me that I have 5 more ATP. If I use that 5 ATP, I feel all 4 for here. Let's stop confusing people. Because I see no reason why you tell me to go to your fridge. I say I'm thirsty. I come your house, I say I'm thirsty. You say go fridge, go carry this thing. I go fridge. I see water. I can't see one container, maybe like ice cream. I don't know now soup you put for inside. Because maybe they feel say you get money. Maybe the teacher never and me just dey back. Like let's be please. At least if you know you want to use the container, put soup. Remove the Valina beauty strawberry brand. Remove one from the top. What do you mean strawberry? I can't say okay, make I just open and have I see your bonus. Please, let's be careful, please. Those well, after all, fake it till you what? Make it. Okay. Life was good when we were little. Once they all bring bread, come house, we know they sleep again. No, they always bring bread on Friday evening. We don't already know say Saturday morning akara and bread. You can't dey wake up in the morning. As 10 o'clock you go open fridge, you see where the bread. You can't dey wait like when they tell your junior brothers, "Na your carry." I don't know if you, that sliced bread. I don't know if you like the last part. Hey, okay. Go tell them, "Na your carry." Life was interesting then, man. Na bread, Nadia bread na. They no fit dey buy am again. The one wey dey vex me na the 500 naira bread wey dey sell. Just stop doing that. Wetin be that? The bread will just swell up as you all done like psst. Just stop it. All right. Balancing redox reaction. So let's go. Normally, listen. When you are balancing redox reaction, there's a pattern it follows. You will balance from the acidic medium before you balance the basic medium. Are you following? You cannot balance basic medium first. It must always pass through the acidic to the what? To the basic. So let's answer number 6 question first before we answer number 5. So number 6 will show us how to balance in acidic medium. I just hope this equation is correct. I don't want to solve 2 times. Please, now if you are doing that, I beg, stop, I beg. Hey, there's a problem here. I think this equation is this equation correct? Let me check. Number 6. That first equation. I don't want to solve 2 times. Is it correct? Check the past question. Number 6. Who have the normal past question? Check the question for me, number 6. That's balance in acidic medium. Or, okay. Yes, check for me first. Let's do number 5. Let's do number 5 first, while we are confirming number 6. Number 5 said MnO4 minus MnO4 minus plus iodine minus to give MnO2 plus iodine. Is it's not the same? Eh? Eh? Let me see.
So they put four here, and they added two in front.
Okay. I think this one is wrong too. Okay, let's use what we have first. Okay, let's use this. Check this one. Check this one too. Have you seen this particular one? Basic. Is it the same? What I wrote, is it the same?
Yes.
Is it the same?
Yes.
Okay. There's minus minus. Okay. All right. Let's use this one. Let's use this one. Abel. So when you want to balance redox, first, the word redox means reduction and what? Oxidation. So when you want to balance, the first step is you split the equation into two half reactions. This is a full complete reaction. So you split it into two. So this one is the one producing this. This is the one producing this, right? So if I want to split it, I'll say first one MnO4 minus produce MnO what? 2. So this is the first one. Then the second one, I minus give me I2. This is what? Second. So I just splinted this reaction into two half what? Reaction. So after splitting, the next thing you do, you will balance the atoms. You balance the atoms. So we have one more of this, right? And we have one more of this. So this one is balanced, right? Eh? Okay. So we have one more here, right? I mean, do we have how many atoms do we have here? 2. So to balance this, I'm going to add 2 here, Abby. Eh? So I have 2 here. Sure, you understand these points? Okay. The next thing you do is after balancing, okay, now I have one more of permanganate, one more of permanganate, 2 moles of iodine, 2 atoms of iodine, which is still like let us say 2 moles too. You get 2 atoms, 2 atoms, so it is balanced. So the third thing you do is you balance the charge. You balance the charge. So there's an invisible one here. 1 times minus is minus 1, right? So the charge here is minus 1. But the charge here is not minus 1. Are you following? The charge here is not minus 1. The charge here is 0. There's no minus, there's no what? Plus, right? So to balance this charge, I will have to bring electron because electron is negatively charged. You get. So I have to bring electron. But if I'm bringing the electron, will I put it here or will I put it here? I put it here, Abi. So I'll now bring electron. How many electrons will I bring? 2, 4, 5, 6, 1. 1 because it's minus 1. So I'll bring 1 electron. So that I'll have minus 1 here. I will have minus 1 here. So that one is for charge. So let's do the same thing for this guy. Wait. Confirm this equation. It's not correct. There's a mistake. Let me see. Please hold on.
It's a 30.
Where is the mistake coming from? That's why I said there's a mistake somewhere. Okay, I've seen it. I've seen it. Sorry. Let's go back again. So split the reaction MnO4. Now not even show me to give MnO2. Then I minus to give I2. So let's balance atoms first. We have one atom of manganese, We have how many? 4 atoms of oxygen. We have 2 here. So it is not balanced. You have to balance the oxygen. I made a mistake before. Whenever you are balancing for oxygen, you introduce water because the water will produce the oxygen you need. Do you get it? So plus, but if I want to introduce water, how will I know the numbers of water I need? Since here is 2, here is 4, I need 2 oxygen atoms, right? So I add 2 molecules of what? Water. So I'll have 2H2 what? O. So that I'll have 2 oxygen plus these 2, 4 to balance this 4. But when I was trying to balance this, I introduced hydrogen, right? Now, how many atoms of hydrogen is here? 4. So to balance the hydrogen, I will have to put hydrogen here too. But if I'm putting the hydrogen, it's going to be hydrogen ion. So I'll now say plus 4H plus. Do you get it? Eh? So the trick is this. When you are balancing in acidic medium, you use 2 things. You use 2 ingredients. Oxygen to balance the water to balance the oxygen, hydrogen ion to balance the hydrogen atom. So when I introduce this, the oxygen is not balanced, but in that process, hydrogen was formed. 4 atoms of hydrogen. So I'll put 4 hydrogen ions in this side so that I'll now have 4 hydrogen ions, 4 hydrogen too. Do you get it? So here I have 1, I have 2. So to balance this, I will introduce what? 2 here. So the atoms are balanced now. So the next thing I will do is I'll now balance the charges. Now, to balance the charge, let's start from this one. Sorry, let me put enough space under here so that you'll be seeing the picture. So let's balance the charge. This is 4. 4 times plus, that is 4 plus 4, right? So we have plus 4 here. 1 times minus 1 here. Abi? So plus 4 plus minus 1 is what? Plus 3. Plus 3. Where is the charge here? 0. So to balance this charge, I have to neutralize this guy to 0, right? And for me to neutralize this guy, I have to bring electron, which is negative, to balance it so that you cancel out. Abi? Now, how do I know the numbers of electrons I'm bringing? 3 minus 0 is what? 3. Abi? So I'm bringing 3 electrons. So I'll bring 3 electrons and I'll add it here. So I now add 3 electrons here in terms of plus, and I say plus 3e minus. So let's check the charge now. This is plus 4, minus 3 plus minus 1 is minus 4, right? So plus 4 plus minus 4 is what? 0. So here will now be 0, here will now be what? 0. So let me do same thing for here. The charge here is what? 2 times minus, that's minus 2. Abi? Here is what? 0. Abi? So to balance it now, I will bring electron to which side? This side or that side? That side. I mean, am I introducing 2? So I'll now say plus 2e minus. So that I have minus 2 here, minus 2 here. You think clear, Abi? Eh? Do you understand? Should I do it again? Okay. The reason I'm doing it again is because this one will help me to do acidic basic. So I'm using one stone to kill 2 birds. I don't get time to dey kill one bird, go back to that forest again. I no dey go forest. Let me do it one more time. Okay. So step one. Step one. Break reaction into 2 parts. So we have M, let me do it here. MnO4 plus to give MnO2. This is minus. And the second one is I minus to give I2. Sure you understand, Abi? You can do this one now. Everybody can do this. After you have broken into 2 parts, balance the atoms. One manganese atom, one manganese atom. 4 atoms of oxygen, we have 2. So to balance the oxygen, I will use water. Since I need, since here is 4, here is 2, 4 minus 2 is 2, I have to introduce 2 molecules of what? Water. So I'll now say plus 2H2O. So that these 2 oxygen plus these 2 will now become 4, which balances to be 4. But while I was doing this, I introduced hydrogen and I introduced 4 atoms of hydrogen. To balance that, I will introduce 4 hydrogen ions in this side. So I'll now say plus 4H plus. So you use water to balance the oxygen. You use hydrogen ion to balance the what? Hydrogen. This is in acidic medium. Now, when you are balancing acidic medium, what you are trying to do is that you are trying to produce hydrogen ions. Because if a solution has many hydrogen ions, it becomes acidic. But if it has many hydroxide ions, it becomes what? Basic. So we are trying to produce hydrogen ions. And you only get that from where? Water. So that is it. So let's come to this side now. The atoms is balanced. 4 hydrogen, 4 hydrogen, 1 manganese, 1 manganese, 4 atoms of oxygen, 2 plus this 2, 4. So it is balanced. Atoms is balanced. Come to this side. This is 2 atoms. This is 1. Just introduce 2 here. So this one is balanced. Step number 3. Balance charges. This is 4 times plus. This is plus 4. So we have plus 4 here. This is 1 times minus 1. We have minus 1 here. There is no charge, so automatically this is 0. Plus 4 plus minus 1 is equal to plus 3. I have plus 3. So neutralize this plus 3, I will bring plus 3e minus. So that both of them will cancel each other. Then I'll add plus 3e to this equation. So if I add plus 3e now, let's check the charge again now. It becomes minus 3 plus 4 minus 1. This is equal to what? 0. It makes sense, Abi? Okay. This one is 2e. This is 2 minus, this is minus 2. To balance this charge, I have to bring -2 to this side, and I can do that by bringing 2 electrons. So I'll say plus 2e minus. So that here will become -2 also. -2, -2, both of them will now be what? Balanced. Now, after balancing atom, first step was split, second balance atom, third balance charges. Now the charges and atoms are balanced. What do you do? We are not trying to eliminate the electrons. We don't need the electrons. We want to eliminate the electrons. These electrons, we want to eliminate it. The only way we can eliminate the electrons is if they are the same number, the same value. Are you there now? So what will I do? I will watch. I will ask myself, since if here was 2, I'll just cancel out. But since here is 3, here is 2, I will say, what will I multiply by this that will give me a number that if I multiply this with another number, I will get that same number. For example, if I multiply this by 2, I'll get what? If I multiply this by 3, I'll get what? Okay, 6, abi? So what you do now is that you now multiply this whole reaction by 2. You multiply this whole reaction by what? 3. The goal is to make both the electrons have same value so that we can remove them. So let's multiply this by 2 now. If we multiply this by 2, it become 3 times 2 will give me what? 6, abi? Okay. 6. 4 times 2 will give me what? 8, abi? 1 times 2 will give me what? 2. 1 times 2 will give me 2. 2 times 2 will give me what? 4. Then let's come to this side. 2 times 3 will give me what? 6, abi? 1 times 3 will give me 3. 2 times 3 will give me what? 6. So now they have the same charge, the same electron, sorry. 6e, 6e. The last before the least. I will cancel the charge. So I will now join the equation back again to form one equation. So this is how you join it. Add these two before this, then add these two before this. I follow it now. So I will now say 8H plus 2MnO4 minus plus 6I minus to give me, then you now come back to the top, 2MnO2 plus 4H2O plus, you now add this one, 3I2. So this is the complete reaction in acidic medium. So it's very easy. Complete reaction in acidic medium. But the question says balance the reaction in basic medium. So in the reaction in acidic medium, whenever they give you questions in acidic medium, this is how you solve it. This is how you solve it. Now, if I want to balance the basic medium, because this question says balance the basic medium, what will I do? Basic medium is very easy. I will introduce hydroxide ion. Now, the reason why this guy is in acidic medium is because of this. This guy signifies acidity. So if I want to now balance this reaction in basic medium, I will neutralize this guy by introducing what? Hydroxide ion. So if I introduce hydroxide ion, this guy will leave. Hydroxide ion will now be present. Are you following? So in basic medium, what you need to do is, after finding an acidic medium, look at the hydrogen ion. Ask yourself, how many hydrogen ion do I have? Since in my reaction rate is 8, meaning I'm going to introduce 8 hydroxide what? Ion. Now when I'm introducing 8 here, I'm putting both 8 hydroxide ion here and also where? Here too. Do you get it? I'm putting it here, I'm also putting it here too. So since it's 8, I'm going to put 8. Now, if you put, this is 8H plus. If you add 8OH minus to this guy, you are going to form 8H2O. Do you get it? If you, since this is H plus, if I introduce 8 molecules of hydroxide ion, I'm going to form 8 molecules of what? Water. So when I add 8OH to this plus 8OH minus, I'm going to also add plus 8OH minus here too. I'm adding it in both reaction. So this one will convert to what? Water. This one will convert to water. So I will now have 8H2O plus 2MnO4 minus plus 6I minus to give me 2MnO2 plus 4H2O plus 3I2 plus 8OH minus. So you see that the reaction has changed hand from hydrogen plus to what? Hydroxide. That is in basic medium. Basic medium, the only thing that you should be seeing in your equation should be what? Hydroxide ion. So that is it. Now there's a last thing you need to do. The last thing is called simplifying the numbers of water molecules. We have how many here? 8, Abby? We have how many here? 4. So what will I do? I will subtract the smaller one from the bigger one. So I'll say 8 minus 4. That will give me 0 there. Making here remaining how many? 4. So the final equation, when I subtract 4 from this, becomes 4H2O plus this. You get? So that is it. I simplified the reaction to the what? To the lowest grade by removing 4 molecules of water. So this is the answer when they ask you in basic medium. So is there an option that tally with that? Huh? Which option? Which option is that? Is it A? I think it's A. No, it's not A. It is what? It is A. Is it A? A, right? Is it A? Eh? Check very well. Check check the past question. Check the answer, the one in the past question. Maybe there was a typo error. None of the above. Okay, so the answer is none of the above, which is E. So that question, in case you see it, it is E, none of the above. Is there still anyone I can solve? To just make to just okay, let me explain this question for you. This let's do 57. 27. I'm coming. Let's do this 57. Eh? I'm coming. Let's do 57 first. Check 57. That particular question. Let me explain why the answer is this proportionation reaction. Can I wipe my board? Okay. Don't worry, I'll still solve one more redox before, because that is the last one. Is there any other questions? The rest are easy now. Like we have finished all the major questions. The other questions left are called practice questions. So when you get to, you have something to just do instead of. How many of you are watching Behind the Scene, that movie? Behind this, don't lie, just raise your hand. Behind this, okay. So you have more time to watch Behind the Scene. Any exam you have around 11:30 is it's actually a sweet exam. You have time to sleep, wake up, eat, bath, do what you want to do. So it's actually a sweet exam. But you see 8 a.m. and 3 p.m. exam. When you write 3 p.m. exam from 3 to 6, then you know that 3 hours is not actually too much to sit down. To not even be enough.